Imagine a place in the universe where gravity is so intense that not even light can escape. A place where time itself twists and warps, and where the rules of physics, as we know them, seem to break down entirely. Welcome to the enigmatic world of black holes, the most mysterious objects in the cosmos. These aren't just cosmic vacuum cleaners sucking up everything in their path. They are gateways to understanding the universe's deepest secrets. How do black holes form? What happens if you fall into one? Could they hold the key to unlocking the mysteries of the universe's birth and its ultimate fate? Buckle up, because we're about to dive into the mind-bending world of black holes, and trust me, what science is uncovering will leave you speechless. Let's start with the basics. A black hole is born when a massive star, at least 8 times the size of our sun, runs out of fuel. After burning through its hydrogen, helium, and heavier elements in a furious cosmic furnace, the star can no longer support its own weight. Gravity takes over, crushing the star's core into an unimaginably dense point called a singularity. This is where things get weird. The singularity has no size and no volume, yet it contains infinite density. Surrounding it is the event horizon, an invisible boundary where the pull of gravity becomes so strong that nothing, not even light, can escape. That's why we call them black holes. They're literally invisible, swallowing light itself. But here's the kicker. Black holes aren't just rare oddities. They're everywhere, shaping the universe in ways we're only beginning to understand. You might think of black holes as destructive forces that gobble up anything that gets too close. But they're far more than that. Scientists now believe black holes are cosmic architects, playing a starring role in the formation of galaxies. At the heart of nearly every major galaxy, including our own Milky Way, lies a supermassive black hole, millions or even billions of times more massive than the Sun. How did these monsters get there? Nobody knows for sure. But one theory suggests they formed in the universe's chaotic infancy, when massive clouds of gas collapsed under their own gravity. These early black holes grew by devouring surrounding matter over billions of years, becoming gravitational anchors around which galaxies formed, pulling stars, gas, and dust into the spiraling cosmic dances we observe today. Let's focus on our own galaxy for a moment. At the center of the Milky Way lies Sagittarius A, a supermassive black hole weighing about 4.3 million times the mass of the Sun. Astronomers discovered it by observing stars near the galaxy's core, whipping around at dizzying speeds, some moving at millions of kilometers per hour. Only something as massive and powerful as a black hole could explain such motion. In 2022, the Event Horizon Telescope gave us a jaw-dropping gift. The first ever image of Sagittarius A, a glowing ring of superheated gas swirling around its event horizon. That image wasn't just a pretty picture, it was proof that black holes aren't just theoretical. They're real, and they're shaping our cosmic neighborhood. Black holes don't just sit quietly at the centers of galaxies, they can be ferocious engines of creation and destruction. When matter falls toward a black hole, it forms an accretion disk, a swirling ring of gas and dust heated to millions of degrees as it spirals inward. These disks can outshine entire galaxies, releasing energy in the form of blazing light, X-rays, and even jets of particles that shoot out at nearly the speed of light. These jets can stretch thousands of light years, carving paths through space and triggering the birth of new stars by compressing gas clouds. So, in a strange twist, black holes, the ultimate destroyers, are also cosmic creators, sparking star formation and sculpting the universe's structure. Now, let's tackle one of the biggest questions. What happens if you fall into a black hole? The answer depends on the black hole's size. If you fell toward a stellar mass black hole, one formed from a collapsed star, you'd face something called spaghettification. Yes, it's as wild as it sounds. The black hole's gravity would pull harder on your feet than your head, stretching you into a long, thin strand like cosmic pasta. You'd be torn apart before crossing the event horizon. But if you fell toward a supermassive black hole like the one at the Milky Way's center, the tidal forces are gentler because the event horizon is much larger. You might cross it without noticing, at least at first. Once inside, though, you'd be cut off from the universe. Time would slow down relative to the outside world and you'd plummet toward the singularity, where physics as we know it ceases to exist. What happens at the singularity? Nobody knows. It's a place where our understanding of reality breaks down. This brings us to one of the wildest ideas in modern physics. Black holes might not be the end, but a beginning. Some scientists propose that black holes could be gateways to other universes, or even shortcuts through our own called wormholes. Picture this. You enter a black hole, and instead of being crushed, you emerge in a different part of the cosmos, or a different cosmos entirely. While this sounds like science fiction, it's rooted in the mathematics of general relativity, Einstein's theory that describes gravity. Wormholes are theoretical, and we have no evidence they exist. But the fact that black holes push the boundaries of physics makes them a playground for such mind-bending ideas. Let's shift gears to something even stranger. Black holes don't last forever. In the 1970s, Stephen Hawking revolutionized our understanding by showing that black holes can leak energy. This process, called Hawking radiation, happens because quantum effects near the event horizon create pairs of particles and antiparticles. Sometimes one falls into the black hole while the other escapes, carrying away tiny bits of energy. Over unimaginable timescales, think trillions of years, black holes can lose enough mass to evaporate completely. When they do, they might release a final burst of energy, like a cosmic firework. This discovery was a game changer, linking quantum mechanics and gravity. Two fields scientists are still struggling to unify. So why do black holes matter to us, sitting here on a tiny planet in a vast universe? Because they're not just curiosities, they're key to unlocking the biggest questions in cosmology. For example, black holes might hold clues about the universe's earliest moments. Some theories suggest that tiny primordial black holes formed fractions of a second after the Big Bang, when the universe was a hot, dense soup of particles. If these mini black holes exist, they could explain some of the universe's missing mass known as dark matter. Finding evidence of primordial black holes would rewrite our understanding of the cosmos's infancy and its evolution. Black holes are also helping us test the limits of physics. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected ripples in spacetime caused by two black holes merging 1.3 billion years ago. These gravitational waves, predicted by Einstein a century earlier, opened a new window into the universe. Since then, LIGO and its partner observatories have detected dozens of black hole mergers, revealing black holes in sizes we didn't expect, like intermediate mass black holes that bridge the gap between stellar mass and supermassive ones. Each detection is like a cosmic puzzle piece helping us understand how black holes form, grow, and interact. But the real excitement comes from what we're learning right now. In 2025, astronomers are using cutting-edge telescopes like the James Webb Space Telescope, JWST, to study black holes in unprecedented detail. JWST's infrared vision allows us to peer into the hearts of distant galaxies, where supermassive black holes are actively feeding, releasing torrents of energy that light up the cosmos. Just last year, JWST spotted a black hole in a galaxy 13 billion light-years away, meaning it existed when the universe was just a few 100 million years old. This discovery stunned scientists, suggesting that supermassive black holes formed much faster than previously thought, challenging our models of the early universe. Black holes are also teaching us about the stuff we can't see, dark matter. This mysterious substance, making up about a quarter of the universe's mass, doesn't emit or absorb light, but its gravity affects how galaxies and black holes move. By studying the orbits of stars around black holes, scientists are mapping dark matter's invisible web, which holds galaxies together. And then there's dark energy, the force driving the universe's accelerating expansion. Some theories suggest black holes could be linked to dark energy, perhaps through their evaporation or their role in cosmic evolution. If true, black holes might hold the key to understanding why the universe is speeding up, a mystery that has baffled scientists for decades. Let's zoom out for a moment. Black holes aren't just about science, they're about imagination. They capture our curiosity because they're so extreme, so alien. They challenge our understanding of reality, forcing us to confront questions about space, time, and existence itself. What's inside a black hole? Could they connect us to other universes? Are they remnants of the Big Bang or something even stranger? Every new discovery brings us closer to answers, but also raises new questions, reminding us how much we still have to learn. Take the phenomenon of quasars, for example. These are among the brightest objects in the universe, powered by supermassive black holes devouring matter at incredible rates. Quasars can shine 1,000 times brighter than their host galaxies, visible across billions of light years.